This video should be everything you need to know for paper 2 in under 1 hour. Now that paper 1 is over, whether you did well or you didn't do so well, you might as well just completely forget about it and move on to this exam. Can't change anything that's happened in the past. It's best to just focus on this particular exam and see what happens. The first topic is computational thinking. This allows us to take a complex problem, understand what the problem is, and develop possible solutions. There are 3 different types that you need to know: decomposition, abstraction, and algorithmic thinking. So there's 3 methods. Decomposition is when we break down a complex problem or system into smaller, more manageable parts. An example of this is when we use a structure diagram to help develop a program. Abstraction is when we focus on the important information and ignore the irrelevant details. And algorithmic thinking is when we develop a step-by-step solution to the problem. One tool that can be used for algorithmic thinking is a flowchart, and we need to know these flowchart symbols. The most common ones that we will see is the start and end symbol. It's called the terminator. We have the process symbol, which is the rectangle. Any decision is using a rhombus, and the input-output data symbol is the parallelogram. You won't often see a subroutine box, but however, you might see them on the odd paper. This is an example of a flowchart when you put all of the symbols together. So you can see that the start and stop symbol are always used at the beginning and the end of a flowchart. You will often see the input symbol near the beginning of the program. Any sort of calculation or anything that is actually happening from inside the computer is called a process, and that is the rectangle. You will notice when there's a decision, it can go in 2 different directions, either yes or no. So you can see how a flowchart is put together. You need to know how to put these symbols in place. Obviously, you need to be able to read and write algorithms, and in the test you will probably need to write at least 3 different algorithms. Some might be already partly completed and you have to just fill in the gaps. Some of them might be from scratch. If you have to write them from scratch, remember to follow these steps. Read the question carefully, pick out any key variables you will need and give them a sensible name. Think which variables need to be set as inputs. Think about any calculations that might take place in the algorithm, and then think about any if statements you might need for any decisions. Think if it mentions any repetition and which loop you might use, either a for or while loop. And also plan it out before you write your answer, otherwise it ends up looking really messy and you might forget something. Obviously, by now you should really know how to program. You should really know how to do some programs in Python. If you don't, then I advise spending a little bit more time going over some of the algorithm challenges and following those videos just to get them fresh into your brain. As mentioned before, a structure diagram is a decomposition method. It might be one of those obscure topics that comes up on the exam, and it's not really a big topic, then you don't do a lot of it, so it might be something that you have forgotten. So a structure diagram is when you show a larger problem broken down into smaller chunks. It's a type of decomposition. Sometimes they refer to it as divide and conquer because it's dividing a large problem into small problems so it can be conquered more easily. This could be that it's like the main game or the main program, and it's broken down into separate sections that allow you to work on those sections individually. Trace tables are another topic that are very likely to come up on your exam. It's a way of testing to see whether you understand how to actually track a program. Now usually this will be with some sort of iteration where there's a loop involved, and it's so that you understand the kind of changes in the variables through the program as you go through the loop. So a trace table actually helps you to follow your way through a program. It's a really useful way of testing to make sure there's no logic errors in the program. This example here is setting y as 3 as an integer, and then it's starting a loop where it's going to do x in the range of 1 to 4. So in the trace table you can put the column of x as 1, 2, 3 and 4 because that's how many times it's going to go through the loop. And for each iteration of the loop you have to keep track of what's happening in y. So for the first time y is set to 3, but then during that loop y is added to what x currently is, which is 1. So in that first loop y becomes 4. Then when the next loop starts, x is obviously now 2. You do 2 plus 4 and you get 6. And it's just a way of tracking the values of x and y as you go through the program. Now remember, this is just revision, so if you do want to go back over trace tables, there's a whole video on trace tables that you can watch, or you can have a little practice of them. This exam question was from a past paper, and you can see here that you get given the program on the left hand side and you have to fill in this table. Now this is what the answer would be. Sometimes to study the answer helps something click in your brain and helps it to make sense. Really what you should be doing is in the trace table, I imagine that the trace table will already be drawn for you or already be part completed. What you have to do is put each variable in the columns, like here, x and y, and then what the output is going to be. Now if that table is already drawn for you, like it is in this test, you have to just put in what the values would be. So x and y are starting off at 15 and 0, and then once that loop starts, you have to show the changes to x and y as you go through. At some point the loop is going to end when the condition is no longer true. In this case, once x gets to 0, it's not bigger than 0 anymore, which means it doesn't loop. So just have a little study of this. Go back and watch the video if you're really struggling, but I've got a feeling that trace tables are going to pop up. Now we go on to the search algorithms. There are two search algorithms, linear and binary search. A linear search can be used on any list. It doesn't have to be in order. And it essentially just checks each item in the list to see if it's a match. And then it stops when it finds it. Linear search has some advantages and disadvantages. The advantages are that it's a simple algorithm and it can be used on any list that doesn't need to be in order. The disadvantages is it's inefficient, especially for large lists, and it's very slow, especially for large lists. Here is a worked example where you've been given a list of numbers, and this particular list of numbers are actually in order, but doesn't have to be. Now, when you are searching for the number 99, you literally go in order starting from the first item. And on the exam paper you need to show that you are doing this. So you can write it in various different ways, but you can say essentially that 7 is not equal to 99, 21 not equal to 99, and so on until you get to 99. So you need to show the examiner that you understand that it searches each item in order until it finds the correct one. A binary search is slightly different. This time the list does need to be in order, and you follow these particular steps. So firstly, you find the middle item, midpoint. So the midpoint is the middle item, that's the first step. Now you need to note that if that is the actual item you're looking for, then you don't go any further, you've found the item. Then you compare it to the item that you're looking for. Then you remove the second half of the list or the first half of the list, depending on if it's greater than or smaller than the number you're looking for. And the next step is to repeat. So when you look at an example, it will become a lot easier to understand, but it's really worth remembering midpoint, compare, remove, repeat. Midpoint, compare, remove, repeat. The benefits of a binary search are it is far quicker and more efficient. The disadvantages is that the list already needs to be in order, and it's harder to code than a linear search. So here is a worked example of a binary search. You've got your list, it's already in order. The first step is to find the midpoint, which is 68. Once you know the midpoint, you are comparing the value you are looking for, which is 99, to the value in the midpoint, which is 68. Now you know that 68 is less than 99, you can remove the number 68, 59, 52, 21 and 7. So once you get rid of those items, you are now left with a new list. The new list is 92, 94, 99, 133, and you repeat those steps again. So on this slide here, you can see midpoint 68, compare 99, remove those numbers and repeat. The new midpoint is actually 99, so therefore the item is found. The only sticking point on the binary search is some people struggle to find the midpoint if there is an even set of numbers. The easiest way to explain it is always round up. So if the middle is not actually pointing to a number, always look to the one to the right by rounding up. Now we are on to the sorting algorithms. It says the bubble sort algorithm is used to sort an unordered list of items. All sorting algorithms are used to sort an unordered list of items. The algorithm for bubble sort is very simple to follow, but can often take a while to actually sort a list. These are the steps that it follows, so it compares the first two items and it swaps them if needed. Then it moves the bubble onto the next two items and repeats the first step. It repeats this for the whole list, and that once it gets to the end, it's called the end of the first pass. Now it repeats the entire process again until the list is sorted. The benefits of a bubble sort is it's quite a simple algorithm. It's also quite an efficient way to check if something's in order. So if the list is already sorted, it's quite an easy way to just check that it's already in place. It also doesn't use much memory as there's no new items to create. The disadvantages is it can be quite inconvenient, and it definitely does not cope well with large lists. What we mean by inconvenient is you always need to do at least one pass, even if the list's already in order. Here is an example of a bubble sort. There are various different ways to write out your answers, but you essentially want to show the examiner that you understand how the algorithm works. So you could show that you understand that the bubble moves and swaps the numbers where necessary, as you can see in this diagram. And then you need to make reference to the fact that you know it does multiple passes. So once you've done the first pass and you've shown how the swaps work, after that you could either do the swaps in your head, you can note them down on the paper, it's up to you, but you could show what they look like at the end of the second pass, third pass, however many passes that it takes. Insertion sort is where we look at the second item in the list. We compare it to everything to the left and insert it into the right place. We repeat step 2, but we move the pointer along to the right until the last value is inserted in the right place. Insertion sort is a very intuitive way of sorting things. It's also easily coded, and it's good for small lists. It's also very quick. The disadvantage is it doesn't work well with large lists, and it often in the code has to create a completely separate list to sort the new items into. The easiest way to get into this kind of idea of insertion sort is to use the pointer. So you can write out the list of items as they already are on the exam paper and point the pointer to the second item in the list. If this needs to move, then you move it straight away. If it doesn't, then you can leave it where it is. Then you move the pointer along to the next word in the list, and you keep repeating this process. Now on each line, every time you have moved the pointer, you should be moving a value into the correct place, And if you do this, then obviously the word that the pointer is pointing to will change as you move along. So it's all about the pointer, all about the blue arrows that you see here. As long as you move the pointer along and then move the word into the right place and write out the new list, it should work nicely. The final sorting algorithm is merge sort. Now this one, you literally split the list in half and repeat that step until each list has got one item. So it usually works out that you split, 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 or maybe even 4 times. Then you merge the pairs into the right order as you go back up again, and repeat the merge steps until you've merged all the sub lists together. The advantages of a merge sort is it's very efficient, very fast for large lists, and it's got a very consistent running time, which means no matter how big the list is, it seems to run a very similar speed. The disadvantages is it's obviously slower for small lists because you have to split, even though with an insertion sort or a bubble sort it would probably go through them much quicker. Disadvantages is it would still go through the split and merge process even if it's already in order, and it uses a lot more memory because you are splitting values into lots of different data segments. So here you can see the example with the letters at the top, and it's split, split, split. Once they're all individuals, you merge them back together again. Now it's worth mentioning at this point that based on paper 1, some of the stranger questions where it was not typical to what you're used to seeing is most of you can probably do all of the search and sort algorithms, but just be prepared that it might come up with questions asking you about which one might be more efficient than another, which one might be faster than another, which one might use more memory, things like that, which you should be able to get a concept from reading through the benefits and drawbacks of each. Now we are onto the programming section, and the first thing you need to know is a variable. A variable is a named value with a designated section of memory which can change during the program. The tip to spot them in the code is it usually has the word input next to it. So it could be something like x equals input, y equals input. You would know that it's a variable with the word input next to it. A constant is similar to a variable in the sense that it is a data value with a name and a designated area of memory. However, a constant cannot be changed during the program. Why would you want to do that? It's because it can save memory space. Examples of constants would be things like pi is 3.14, VAT equals 20. It's usually something that is set at the start of the program and you will not see it change throughout the program. Program flow is how the program actually flows between line 1, 2, 3, 4, 5, whichever order the instructions run in. There are 3 different types of programming construct: sequence, selection, and iteration. Sequence is where instructions are processed in order, selection is where there is a decision to be made, and iteration is where instructions are repeated. Now these can be identified in code, and it's a very common exam question to know which type is used in the code. Now sequence is almost always used, so unless there's a very, very special reason why, sequence will take place at some point, even if it's just instruction 1 and then 2. Selection, look for the word if in the code, or if it's in a flowchart, it will be a diamond or a rhombus shape. Sometimes they might try and catch you out with something called a switch case. Switch case is just a different method of selection. Iteration is you look for the word for or while in the code. If it's a flowchart, it might be a diamond or rhombus shape, but it will usually have an arrow going backwards in the chart. When it comes to iteration, there are 2 types of loop. There are count controlled loops, which is where you know how many times you want to repeat something. These are often used to loop through a list of data. These are called for loops in the code, and you might see something like this image on the right, for I in range. That will repeat however many times you put in the brackets after range. In this case, it's going to start at the number 3 and repeat until it gets to 30. A count controlled loop is where the program will loop until the criteria is met. Look for the word while in the code. You can see in this example here, it says while count is greater than 0, which means that code on line 4 and 5 will repeat while count is greater than 0. At the moment it's 5, so we know that it's greater than 0, so that code will run until count becomes 0. And then the loop will stop and it will then exit the loop. Condition controlled loops and if statements all use comparison operators. It's where you are comparing two values to each other. There are different operators that you need to know. 2 equals means equal to. Exclamation equals means not equal to. The obvious ones that you do in maths, less than and greater than. And to do less than or equal to in code, you do the less than sign and an equal sign straight afterwards. An arithmetic operator is when you are doing some sort of calculation. So plus, minus, times and divide are here. Addition, subtraction, multiplication and division. Mod and div are something that might pop up in your exam because they are a very kind of small topic that floats beneath the surface sometimes. Mod is when you get the remainder of a division. For example, 185 mod 60 would be 5 because 60 goes into 1853 times, but you get 5 left over. So mod is the remainder. And div is called integer division. In other words, how many whole numbers times does it go in? So 185 divided by 60 would produce a decimal. What you need to do is see how many times it goes in as a whole number. So it would be 60, 120, 180. It goes in 3 times with 5 as the remainder. So div returns the 3. Lastly, we've got the exponentiation. Can't even say it. It's when you do to the power of. 2 to the power of 4 is 16 as an example. So whenever you see this symbol between two numbers, it means to the power of. Finally, we've got Boolean operators, and we've got and, or, and not. So you will recognize this from the logic gate. It basically does the same thing. It just means that one and the other must be true. Or means one or the other or both must be true, and not reverses the true or false. So as these examples, if you wanted a true output, you would say 3 is less than 5 and 2 is greater than 1. Both of those are true, so that would produce a true output. Study this table if you are confused, but this is just a revision video. Now we move on to data types. There are 5 main data types that we have in programming. We have integer, real or float, Boolean, character and string. Now you just need to know what each one is in case you get asked for an explanation or in case you get asked to give an example. Sometimes you might be asked what data type it is in a piece of code. In this particular case, an integer is a whole number, real or float is a decimal, Boolean is when something has 2 possible values, usually true or false. Character is one single letter, number or symbol, and a string is a group of characters. Now we move on to string manipulation. A string is obviously one of the data types, and there's various operations we can do with a string. For example, if we've got 2 variables here, string 1 and string 2, and we want to merge them together, then the easy way to do it is to do string 1 plus string 2. Now what that would do is merge those two strings right next to each other. If you want to put a space in, then you'd have to add an actual space inside speech marks. So concatenation is when we join more than one string together. It helps to think of a string similar to a list or an array in that every value inside has its own index. So this particular string turtle has been broken down where the first letter starts at 0. That means we can access individual letters from a string. For example, we could just get the first letter by saying print word and then the 0. So essentially, word is a variable. We've set it as this particular string. If we say print word 0 in square brackets, it will get the first letter. If you did print word 1, it would get the U, which is the second letter along, and so on. There are other various operations you can do with strings. For example, you can convert the whole thing to uppercase or lowercase. You can find out the length of a word. You can extract one particular letter, or you can create a substring of letters. Here's an example of some commands in Python that you might be familiar with. So word.upper would create it into uppercase, word.lower would make it into lowercase. Len of word gives you 4 as the output because it counts how many letters. Word 0 would get the first letter. Word 2 would be W and O because it's from the beginning for the first 2 letters. If you do -2, it's from the back end of the word for the first 2 letters. And if you do 2 to 3, it starts on the second or the third item into the word and then carries on for 3 letters. I'm unsure how they would actually test you on file handling, but I don't expect them to be asking you to write full Python code to do a file handling operation. But what you do need to be aware of are the stages. So file handling, it could be maybe a question where it's a 5-mark question and you have to fill in the gaps using some provided words. If you just remember the 3 steps, that with any file handling, the same with a book, is you have to open the book, so open the text file. Then you're either going to read from it or write to it or add to it. Then finally, when you're finished, you would close. So open, read, close, open, read, close. But just on the second stage, you can either read, write, or add to. You need to have an awareness of how data is stored. Data is stored in databases, and each column is called a field, and the rows are called records. This table here, as you can see, could easily be put into an array in Python. Now what you'd have to do is you'd have to create a 2D array, and each column and row would be put into that 2D array. So even when we are talking about data structures, everything ends up in fields and records in database table format. Databases in SQL. SQL is a structured query language. This can be used to create, update, and query databases. SQL consists of standard commands called statements, and you can join them together. All you need to know is how to search for information. So SQL follows the structure when we are searching. It's select from where. Select from where. You just need to keep remembering select from where, and select. After that, you need to say what you want to select. From, you say which table you want to select it from, and where is the criteria that you are looking for. You can perform complex searches. This is when you have multiple criteria applied. Select star is a wildcard, which means select all. So the asterisk next to select means select all. From, teachers is the name of the table, and then where salary is greater than 25,000, but this time we're putting the Boolean operator in and. So this means that we need the salary to be 25,000 or over, and the department needs to be set to PE. So in this particular case, there is only one answer from that, which is Arnold Schwarzenegger. You can use the criteria which is called like, so where first name like, and then you do P with a percentage, and it will be the first letter P, so that will be Patrick Stewart. If there were multiple people with the P as the first letter, then that would return all of the names with P. You can add more letters in, so you could put PAT, percentage, and that will be everyone who starts with Pat. So the percentage is basically just to say, fill the rest of the word in. Finally, when searching for data, you can use the term order by and say what you want to order it by, and then whether you want it to be ascending or descending. Ascending means to go up and descending means to go down. An array is a data structure that can store a collection of data values all under one name. Whereas with a variable you can only store one value, an array allows you to store multiple. Each piece of data in an array is called an element. Every element can be accessed separately, similarly to when you are using a string. These are very useful when you've got lots of related data and you don't want to have separate variables. A one-dimensional array or a list looks like this. Students equals Dave, Frank, Steve, Paul, and it uses square brackets. This is allowing us to store 4 values under one name. Then if we access individual elements, similar to we did with a string, you do print students and then which item you want to get to. So Dave is 0, Frank is 1, Steve is 2, and Paul is 3. It works exactly the same as a string. A 2D array is slightly different, and this kind of depends on the programming language, but in the exam it will kind of give you an example of which way to do it. Usually you would go along the corridor down the stairs, but I know in some languages it is slightly different and does it the other way around. In the exam it will give you an example so you know which way round you need to go. In this particular case, if we go along the corridor down the stairs, if you do students 1, 1, it goes along the corridor to the 1 column and down to the 1 row, and it gets Rooney. Now we look at procedures and functions. A procedure is a subprogram that carries out a set of instructions and does not return a value. A function is a subprogram that carries out instructions and always returns a value. This means with a function you can use the returned value elsewhere in the program. With a procedure, it will just do the instructions and that's the end of it. An example procedure is shown here, DEF better welcome, and in brackets is a parameter. Now the procedure is literally just saying print hello name and welcome, print let's learn about procedures. So it's just going to run those 2 lines of code, print, print. It's going to run both of those when you run the procedure. So at the bottom, we are running a procedure, just says better welcome, and in brackets, we've put an argument in called Jeff. That word Jeff will get passed into the procedure and get used. So the output will be hello Jeff and welcome. Let's learn about procedures. Here is an example function. Now remember, this is just revision. There is a very detailed video all about subroutines that you can watch, and hopefully by the end this will all make sense, but this is just a recap. To create the function, you define it first, give it a sensible name, and then say what parameters that you want to use. Now what I've done underneath is return x plus y. It's a little bit of concatenation to join 2 strings together. So any values that you pass in as x and y, it will join them together and return it back again. So at the bottom, when I call the function, we've got subject equals, and then we call the function, join strings, and the 2 arguments are passed in. Computer becomes x, science becomes y. They get joined together and returned back to the program. So now subject, if you print out subject, we'll print out computer science together. Parameters are the special variables used to pass values into the program, and arguments are the actual values that the parameters take when the subprogram is called. This is another topic that we didn't spend a massive amount of time on. It's just random numbers. Random numbers are often used in games, whether it's a simple game or even a complex game. For example, it could be the spawn coordinates that are randomly generated. A useful example that you might be familiar with is for a game when you need to roll a dice. So dice roll equals random x comma y would be a simple program that would pass two parameters in, the start value and the top value, and it will literally call a random number. Now in Python we can use the ready-made library and import the function in. So when we import random, we can use the random library. So dice roll equals random dot rand int, so it's going to create a random integer between 1 and 6. Defensive design is when you anticipate misuse of a program and try to prevent it. In other words, you're trying to make programs function properly and make them harder to break. When programs are functioning properly, they should never break and never produce errors. There's two methods that you could think of for defensive design. One is to confirm the identity of a user before you're allowed to use it. One common way of doing this is to use passwords. The name for this is authentication. Defensive design. Another method is input validation. This is to check that data meets certain criteria before allowing it to go into the program. For example, if knights is less than 0, print error. So when the user is being asked to enter how many knights, if they've typed in a number less than 0, then it would be an error. There are two types of error that you need to know. Number one is a syntax error. This is when the compiler doesn't understand something you've typed, usually due to it not following the layout rules or a grammatical error. Examples are spelling mistakes, for example, print instead of print, the wrong indentation, for example, not moving it in to be part of a loop, and another one is missing brackets. A logic error is when the compiler runs, but the program does not do what you expect it to. For example, a calculation might miss a bracket, so it'll do 10 times 2 divided by 3 instead of 10 times 2 divided by 3. Wrong operator is used, for example, if age is less than 18 instead of if age is greater than 18, or an infinite loop because the loop never ends or never breaks. Another link to defensive design is to make your code maintainable. Maintainability is when you make the program easier to maintain, to look after. In other words, easier to understand. Indentation is one way, and it's moving the code in so it's easier to read and spot mistakes. Helps you to follow the flow of the program. Comments in the code help programmers understand what's happening better. Variable names, if they are sensible, is easier to reprogram and understand the program. Finally, if you use functions and procedures, using pre-written code can help to reduce the errors. There are two types of testing that you need to know. The first is iterative testing. This is testing as you go along. It's testing as you add new code. It's a gradual approach, and it means that you're going to test it multiple times. This can be repetitive and time-consuming, but it means that you're not going to wait until the end to spot any mistakes. Final testing is when you do the testing at the end of the project. Now this will take longer at the time, but you do only need to do it once. Testing tables can be used to test the program, and you should use these three testing data types: normal data, boundary data, and erroneous data. Normal data is what you are expected to type in. For example, if you type John when it asks for a name. Boundary data is when the result is on the edge of the acceptable data. For example, if you put 0 in when it has to be above 0. Anything that is on the border of what is acceptable. Erroneous is when you type something completely wrong in. For example, a word instead of an integer. Logic gates. Again, there is a whole video about logic that if you watch it, you will be able to answer any question about logic. But for now, this is just a recap. Logic gates are special circuits built into computer chips. They receive binary data, apply a Boolean operation, and output a result. Logic diagrams are often drawn to show logic gates and circuits. Each gate has got its own symbol. These are the logic gates and their symbols. You need to be able to redraw each. The AND symbol looks like a capital D, so that is the one that's probably the easiest to remember. It has two inputs coming in and one exiting. Now what it means is that both inputs need to be true for the output to be true. You need to know the truth table, or at very least remember the logic. Or just means one or the other, or both need to be true for the output to be true. So with the two inputs coming in, A and B, you just need either one of those or both to be true for the output to be true. And a NOT gate is literally reverses anything that comes in. So if a 0 comes in, a 1 goes out, and if a 1 comes in, a 0 goes out. Note that the NOT gate has one line coming in and the others have two, and the NOT gate has a small circle on the front of the triangle. It is likely that you might either need to look at a circuit and do the truth table, or create a circuit, or tell everyone what the Boolean algebra is for that particular circuit. Now remember the tip where if it hasn't already got the column added in, if there are any gates where there's two inputs coming in, like this particular one where I've added the R column, make sure you add in your own column because it will make the output much easier to calculate. Again, make sure you go and watch the logic video if you are still struggling with this particular topic. You need to be aware that computers have high and low level languages. High level languages are programming languages like Python and JavaScript. Low level languages are machine code and assembly language. High level languages are used because the source code is easier for us to read and write. Computers must translate it into machine code before it can be processed. For example of a high level source code is volume equals width times height times depth. The computer would need to translate that so that it can understand. Low level languages are harder for humans to read and write, but much easier for a computer to run. Machine code is binary, which is essentially just ones and zeros. Assembly language is slightly more readable, like add 12. Translators are used to get those high-level languages into low-level languages. There are two translators that you need to know: compilers and interpreters. The type used depends on the coding language that you've used. A compiler translates all the code at the same time and creates one executable file. Compilers only needed once, and it returns a list of the errors for the whole program. The program will run really quickly, but the compiler takes a long time to complete. An interpreter translates and runs the source code one instruction at a time. This is needed every time you want to run the program. It's usually used for web-based languages like JavaScript. The interpreter will run the first error it finds and then stop. This is really useful for debugging and finding errors. An interpreter runs more slowly as it translates at runtime. This means it translates as it is running. The final topic is Integrated Development Environments, or IDEs. They provide programmers with lots of handy tools when coding. It's a piece of software that provides features to help a programmer to develop their program. Many IDEs have similar features. Here are some of the features that you might need to mention in the exam. Each IDE has a code editor, which basically allows you to type in and change and edit the code, but it has little things such as auto color coding so that you can see when you put strings, functions and loops in. It might also have autocorrect when you are typing. Error diagnostics means that you can highlight errors and suggest improvements to the code. A translator means that inside the IDE you can compile your code. And a runtime environment lets you run and test the program. That is everything that you need to know for paper 2. I would advise making sure you watch this a couple of times, making sure you make notes of some of the words that you might not be so familiar with, things that you might not have covered that many times, like IDEs, translators, things like that. And also, if you are still struggling with logic, functions, anything like that, watch those particular videos. And if you're still struggling with programming, have a little go at the algorithm challenges.